Hi, everyone. My name is David Banton, and I am presenting for my final project in the WebGIS course in the spring semester of 2025 at Johns Hopkins University. And my project is mapping home, a spatial journey to find the perfect apartment. So the purpose of this assignment is finding a home isn't just about the price, it's about feeling connected to your community, having what you need nearby, and living your lifestyle fully to how you view it should be. And the purpose of this project, honestly, is a bit more of a personal one, but it does have applications to a lot of other people. And so some background is my girlfriend and I have been debating for a long time where we want to move into our first apartment. We have lived for a very long time, almost our entire lives, in the city of Richmond, Virginia. And we decided on moving to Philadelphia, Pennsylvania. And we chose the city for a combination of the city's availability of art, culture, and an abundance of jobs in our respective career interests. Um, and it's also the first car trip that we took as a couple to see the Philadelphia flower show. If you haven't been or even heard of it, I highly recommend looking into it. It's an awesome experience, and it happens every year. But back on track, there are a lot of considerations to make when it comes to deciding where you want to live. And in an attempt to make it a little easier on ourselves with everything that's going on in our lives, and to kill two birds with one stone and potentially help others in the same situation as us, but who might have different interests and different cities in mind. I've made a tool to narrow choices for houses or apartment complex. And it only has admittedly a few tools right now, but I think that it can be upgradable and upscalable to meet a lot more than just a couple of the aspects that I'm going to be tackling in this project. So changing residences can be extremely stressful, and it can be compounded by an overwhelming number of factors that need to be considered, from commute times to work and back and forth, to essential services like grocery stores, hospitals, and anything nearby that is necessary for a fully functioning home. But this stress can be further compounded um, with the dissatisfaction of making an incorrect choice, and getting out of leases can be very tricky and difficult, and it can take time because it varies from contract to contract. Some are 3 months, some are a whole year. But having the dissatisfaction of making the wrong choice and figuring out that that you love the apartment and the way it looks, but finding out that the neighborhood is just not what you want, it doesn't have the same demographics as you, can be very stressful. And there's even more complexity when you and your partner, or your um, respective roommate, whatever type of situation, have different needs for what you want to have nearby and what will make your home perfect. And it makes it even more complex for us because we do have pets. So, in our search for housing in Philadelphia, me and my girlfriend do have different needs, and I needed to be able to access libraries to study and parks to walk our dog, and my partner needed a place to access a lot of art galleries and spaces. And also have access to different grocery stores, from local owned to Aldi and all these others. And this creates a perfect use case for a spatial decision support tool. And so overall, this project aims to develop a prototype for a location-based suitability model that anyone can adapt to their priorities. And so this is the study area. This is Philadelphia, Pennsylvania. It has a lot of walkable amenities and culture and parks and green spaces. And there is a lot of different differences between the different neighborhoods throughout Philadelphia, different cultures, and just different aspects. And so this is perfect for demonstrating a suitability analysis model. And so some of the data layers that I went over with, sorry. Some of the data layers that I added, of course, the apartment locations, the potential apartment locations. This is a fictional layer made by ChatGPT, both for my own privacy and just for testing AI's capability in making an importable CSV file for web apps. Of course, I needed to add dog-friendly parks and green spaces, which was collected via ArcGIS's online data catalog. I also added art galleries, and this layer was also made by ChatGPT to test the capability of AI once again. In cases where local governments don't have a refined GIS system or a lack of the specific data on a subject that someone is interested in. This was by no means a challenge necessarily for Philadelphia, but there are some places that just don't have specific data that people need. And so ChatGPT is perfect for this because it can make these models for people who are less experienced in building these CSV files and data layers. Or if there's an overwhelming number of choices, then as we've discussed in previous modules, then AI can be used to automate the process in this decision-making process and also mapping. I also included grocery stores, which was made by modifying a pre-existing layer in ArcGIS's data catalog, and we narrowed it down to places that we like more. Libraries were also collected via ArcGIS Online's catalog, and then transit stops were found on Philadelphia's open data portal. Also, I have embedded the links to all of these because in previous modules and in a lot of other classes, people want to see the data, and they also want to just take a look at the feature layers. And so I have all of these provided. If somebody tests one out and it doesn't work, let me know and I will fix that as soon as possible. And so now on to tools and workflow. The tools mentioned are intended to be used in a step-by-step process on this on this web app, and the instructions are given in the info panel of the web app. Some of these tools will rely on the data from the previous, so it's going to be a step-by-step basis, as I mentioned. But the tools that I have so far in this are the create drive time analysis, where you can make a buffer with varying zones representing the walk or drive time to or from a feature point, which in this case will be apartments. And this will help determine what areas are walkable, since Philadelphia's parking situation honestly is very terrible. Just visiting there, parking can be very expensive and very hard to find. I also have an enrich layer tool, and it basically adds additional input feature information with different demographics, and can be extremely useful for finding areas that have a particular crime rate that is desirable or income level. Specifically in this case, I just went over some crime rate and then also the marital status of the neighborhoods. So like on average, was there two people living in a household? What percentage of people also were married in this situation or divorced? But there is a lot more that can be added into this, and it can meet a lot of people's needs, which makes it more buildable for somebody's own needs. I also have the Summarize Nearby tool, which summarizes the number of features within other data sets. So I can make a layer that will specifically state how many metro stations or libraries are within the specific desired buffer area. So if I wanted to be able to access more dog parks and not just go to the same one over and over again, then I'd be able to pick an apartment that has close walking distance to a lot more. I also have find similar locations tool in here, which allows the user to pick their favorite enriched points and compare them to other candidates that can baseline across multiple variables from previous tools like walkability or the proximity to specific locations or crime rate. And so I can compare several apartments that I really like. And so this is the web app with all of these specific tools. Again, all of the information is over here on how to interact with the web app. I apologize. And you can also add any data that you like. So if you don't even want to do Philadelphia, then you can add data and you can go all the way over to Baltimore if you would like. But specifically for this, we chose Philadelphia. And if you wanted to choose a different apartment complex, other locations, you can use the draw feature. And so this is basically for anybody to use as they desire. And if they want to go with anything different, then they are capable of doing it by just following the instructions and adding their own data. And ChatGPT can make these data layers, or they can find them on ArcGIS Online or the open data portals. All of these are options. So by using this web app and the workflow that I designed, I am better able to choose some of these apartments, and analyzing the walk times is really helpful with the parking situation and walking my dog. I am also more capable of choosing areas that have a specific crime rate and meet more the lifestyle that me and my girlfriend want to live. And if we want to be closer to people that are more our age. The fantastic thing that I want to just highlight one more time is that anybody can add any kind of data that they would like. Since I know that there are probably a lot of people that are around my age right now and are also in this similar situation and trying to leave their parents' household. I think the one area that this could have been further built upon is I really wanted to build an arcade expression, but I have had a lot of issues with that in the past and had a lot of issues with this. So I refrained from it, but I think that I could make an arcade expression in the future to weigh the presence of different features and make a suitability analysis score to further simplify decision making. But you don't have to go and futz around too much with the web app that I built, because I also just made kind of a final map with a presentation of how some of these final products will look. And so I have the summarize area, and it states specifically how many of the metro stations are within the drive times for the apartments that I have selected. I also have similar locations. So I searched how many adults per household are there, how many apartments are there with an adults per household of 2 or less. And so this gives the calculation here. And then for the enriched data layer, whoops. And then for the enriched data layer, I also took a look at some of the aspects that I mentioned, and you can see here that having a little bit of trouble here. Sorry. You can see that it has a I'm having a hard time finding this. I might be also clicking on the wrong. That's what it is. I am clicking on the wrong one. There we go. Sorry about that. You can also see that the average household size is 2.7. The population of ages that are 15 plus and are married in this specific area, or a total of 11,639, and total crime index rating is 124. But that is this is my final map, and this is my final presentation. And thank you so much for viewing this video and viewing all of the hard work that I've put into this. And it was truly amazing listening or looking at some of the discussions that we had this semester. And I hope everyone has a fantastic summer. All right.